Today, we're diving into the universe's hidden architect. It sounds romantic, but the truth is that the universe is not solely made up of the twinkling stars and glowing galaxies we can see. No, there's a larger mystery afoot. You see, around 85% of the universe's mass is actually made up of dark matter. That's right, dark matter. But here's the twist. This stuff doesn't emit any light. It doesn't interact with regular matter the way you'd think, except through gravity. It's like the universe's best-kept secret, subtly shaping galaxies and, ultimately, the cosmos as we know it.
Wait, so you're saying that stars on the edge of a galaxy, they're like driving a race car? Do they have a secret engine behind them that we can't see? Like, how does that all connect to dark matter or, gravity stuff?
Great question. It's not a literal engine, but rather this invisible mass dark matter that's essentially giving those stars an extra gravitational boost. Just like those tireless kids might be applying a secret sauce of speed, dark matter is acting behind the scenes. And it's not just about speed, it shapes galaxies.
So it's like there's this ethereal force pushing them forward? That's wild. Do we have, other evidence that backs this up?
Now, the second piece of evidence is gravitational lensing, which is an Einstein thing. You see, massive objects bend light, kind of like a cosmic magnifying glass. We've observed this in galaxy clusters, like the Bullet cluster. In regions where there's little to no visible matter, yet light still bends. It's almost as if ghostly figures are revealing their presence. Can you imagine how it must feel for astronomers to realize that they're looking at something they can't see directly? It's like solving a puzzle where some pieces are missing.
Whoa, that's like, super creepy but also fascinating. So we're seeing this bending light but can't actually find what's causing it, like a ghost in a haunted house or something? Because I'm kinda getting chills thinking about it.
Exactly. It truly is the ghost of the universe. This invisible matter influences how galaxies are arranged and established while remaining elusive. And if we dive deeper into the cosmic microwave background, or CMB for short, it's the afterglow from the Big Bang, showing us density variations in the early universe. Data suggests that dark matter played a critical role in structuring galaxies.
Wait, so that's like the universe's way of taking a selfie right after it was born? How do they even measure those density variations?
Nice analogy. Yes, you could think of it that way. Scientists measure those variations using satellites like the Wilkinson Microwave Anisotropy Probe, or WMAP. These tiny differences in temperature across the sky give us clues about where dark matter may have influenced the formation of galaxies. It's like tracing the path of a pathfinder hidden in the background of that cosmic selfie.
So it's like they're on a scavenger hunt looking for clues from the universe? That's so cool! But what about all these particles like WIMPs? This sounds like a sci-fi movie.
Absolutely! Let's leap into WIMPs, weakly interacting massive particles, our leading candidates for what dark matter could be. These theoretical particles are predicted by a concept called supersymmetry. Imagine WIMPs as these shy individuals at a party. They're there, but they don't require a lot of social interaction with the crowd.
So it's like introverts of the universe? They're hefty, but they don't want to mingle with us? Do we have any lighter candidates out there? Like, I don't know, if WIMPs were the jocks, do we have, geeky axions or something?
Haha, I love that. Yes, you could say that. While WIMPs are like the heavyweights, axions are indeed the lighter contenders in our cosmic social scene. They've been proposed as possible dark matter candidates, but their detection is still up in the air. The struggle to catch a glimpse of these particles is very real, particularly because, unlike WIMPs, they interact even less, but they're out there, causing quite the buzz among scientists.
It's like they prefer to stay in the shadows while everyone else is partying? But how do scientists even look for them if they barely interact with anything?
Great point. Now, moving on to the hunt for WIMPs. This is where things get even more thrilling. We have experiments like xenon-1t, which use a ton of liquid xenon to try to detect WIMPs. Imagine a gigantic underwater treasure hunt, but instead of diving into the sea, researchers are sifting through a tank of liquid.
Wow, that's like they're trying to catch the ultimate Pokemon, but instead of using a Pokeball, they're just standing around hoping one will swim near? It sounds super rare though.
Yes, that's a solid comparison. It's about minimizing background noise and making sure when an event occurs, it's actually a WIMP and not just something mundane. And xenon-1t even saw a controversial excess of events once. But they didn't catch the elusive WIMP just yet.
Yikes. That's like, being on the verge of a roller coaster and it doesn't really drop. I can't imagine the suspense of waiting for that big, breakthrough.
Exactly. That blend of anticipation and uncertainty is part of what makes the scientific journey so adventurous. Other projects, like LUXZPLIN and PANDAX4T, are also working to up the ante and delve deeper into this dark matter mystery.
So we're casting our nets wide to catch these elusive particles? It sounds like a cosmic fishing trip we didn't sign up for.
Yes, casting our nets far and wide. We also have indirect detection methods, like looking for gamma rays or neutrinos. If WIMPs annihilate each other, they might create these signals, which telescopes are on the lookout for. It's like waiting for the stars to send secret messages, if you've ever thought of it that way.
That's wonderfully poetic. Can we communicate with stars? Like, if we see something, do we get to send them a cosmic text back, or is that wishful thinking?
Wouldn't that be amazing? Sending emojis out there? Right now, though, we're just on the receiving end, interpreting the signs the universe sends us. There's also the Large Hadron Collider, checking for SUSY particles. The technological advances focusing on dark matter detection continue to expand our horizons.
So it's like we're on the phone but can only listen? Super cool! I can't wait to see what they discover next.
As we delve deeper, we encounter philosophical puzzles surrounding the limits of human perception. What if our technology is incapable of detecting dark matter because it interacts through entirely different forces? Just think about that. Some mysteries might remain hidden simply because they exist beyond our current capabilities.
So it's like trying to find Wi-Fi in a tomb? We just don't have the tools to reach out to something ancient? What if there are aliens pointing to dark matter like, "Hey fools, it's just over there"?
Haha, exactly. Perhaps we're all on this grand treasure hunt, equipped only with toy shovels. There are competing alternative theories like modified Newtonian dynamics, but they also face challenges in explaining the universe's structure.
It's like being stuck trying to solve a Rubik's Cube but missing a few colors. Super frustrating.
The excitement continues as we look ahead to future frontiers. Upgrades are coming, with projects like XENONNT and the ambitious Darwin project aiming to elevate dark matter research. And don't forget the Axion search is actively underway, pulling out all the stops to detect these elusive particles.
Okay, I'm getting chills. It's like an ongoing cosmic block party, where new experiments bring in the guests. What if they discover something entirely new? That'd be revolutionary.
Absolutely, it would. The collaboration between various observational techniques, known as multi-messenger astronomy, provides a merging of insights that could shine a light on dark matter's many mysteries.
Whoa! That's like an epic cliffhanger in a sci-fi movie. What's next? Are we ever going to find that elusive dark matter? It's going to drive me nuts.